Good morning, students. Welcome to today's lecture.
In the last class, we have discussed integers and its properties. I hope you have seen the video shared by me on the chapters fraction and decimals. Let's start. Chapter number 2, fractions and decimals. Now, what is a fraction? We all know examples like 1 by 2, 3 by 5, 7 by 2. All these are 7 by 12. All these are example of fractions. In fractions, we have a numerator and a denominator. So I have generalized it and said it is a number of the form p upon q, where q should not be equal to 0. Why? Because if q becomes 0, then this fraction will become undefined. Why? Because suppose you have a number 1 upon 0, you can check it is undefined because in the table of 0 1 never comes. Yes, if p is 0 there is no issue because 0 upon 1 is equal to 0, 0 upon 2 equal to 0, but 2 upon 0 is not defined. Hence we say in a fraction the denominator can never be equal to 0. Okay, now fraction, we have seen some types of fraction, like we have seen proper fraction, improper fraction, and mixed fraction. What do we mean by a proper fraction? A fraction p by q is said to be proper if denominator is more than numerator, like 7 upon 12. You can see the denominator is larger, hence it is a proper fraction. This case again you can see 3 upon 5, 5 is larger, which is the denominator, hence it is a proper fraction. Improper is opposite of it. In this case, the numerator is more than denominator. So we can say if p is more than q, then we call such fractions as improper fractions. Example 12 upon 7. You can see 12 is the numerator and it is more than denominator. Similarly, 5 upon 3. Here also you can see the 5 is more than 3. So these both are example of improper fractions. So whenever we see improper fractions, we try to convert them into mixed fractions. Okay, what do we mean by mixed fraction? Here we simply take the number and divide by the divisor. Suppose 12 is dividend, 7 is divisor. Here 12 is dividend, 7 is divisor. We know 7 ones are 7. Remainder is 5. So see how to write a mixed fraction. First, we write the denominator same, 7 7. Okay, then we write this number. This is the quotient. You can see quotient is 1, quotient comes here, and then we write the remainder above the 7 like this, and it is solved like this: 7 into 1 plus 5. So 7 ones are 7 plus 5 is 12 upon 7. So this is known as mixed fraction. I hope you have studied about this in earlier classes also. Okay. Now, in earlier classes we have also studied the concept of comparison of fractions. By comparison we means we compare two or more fractions for larger, smaller or equal fractions. Then we studied the concept of equivalent fractions. Then we did representation of fractions on a number line, and last setting them in order, that is ascending or descending. If you don't remember these concepts, don't worry, I will revise this one by one. Okay. Now, first definition of proper fraction. A fraction that represent a part of a whole is known as proper fraction. What do we mean by this? Whole means complete, and part is some part of that complete. Like you get marks in examination, you say I have got 27 out of 30. So this 30 is the whole or the maximum marks. 27 is a part of it. So it is okay. No issues here. So we call such fractions as proper fractions. One more hint I gave you in the last slide also, that if the denominator is larger than numerator, such fractions are known as proper fractions. But have you ever heard that someone has got 30 out of 27? No, that means it is a improper fraction, because here it is saying that whole is less than part, which is not possible. Whole should be more than part. So this fraction is improper. So we will try to make it proper or mixed fraction. Now see, second part, that is improper fraction. Improper fraction is a combination of whole and a proper fraction. So let's see how we can break a improper into whole plus proper fraction. For that, we have already discussed the process. Just see it one more time. Suppose I take this example only, that is 30 upon 27. In this, 27 is the divisor, 30 is the dividend. So 27, 30, 27 ones are 27. Remainder is 3. I told you to write the mixed fraction. First we write the denominator, like 27, 27. Then we write the quotient in front, like this 1. Then we write the remainder above. So it is the mixed fraction. So as the definition says, it is a combination of whole and proper fraction. You can see this one is the whole and this 3 by 27 is the proper fraction. So we have successfully represented a improper fraction in the form of whole and proper fraction. Got it? Now, equivalent fraction. What do we mean by equivalent fraction? Suppose a question like this comes, write 5 equivalent fraction of 3 upon 5. First of all, if I write like this 3 upon 5 into 1 by 1, does it change anything? No, because if you multiply them, you again get 3 upon 5 only. So this 1 by 1 doesn't change anything. Okay. Now, using this concept only, I am trying to find some fractions like 3 upon 5 into 2 by 2. You can see this 2 and 2 can cancel. Again, you will get 3 upon 5. So I am using the same number but increasing it. So it becomes 3 twos are 6, 5 twos are 10. This 6 by 10, although looks different, but it is actually equal to this only. That is 3 by 5 and 6 by 10 are actually equivalent fractions. Why? Because if you cut it by 2, you can check 2 3s are 6 and 2 5s are 10. You will get 3 by 5 only. That is why this 6 by 10 is just a form of 3 by 5. Similarly, you can find more equivalent fractions, as I have taken this example 3 upon 5 into 3 upon 3. You can see we have got 9 upon 15. Similarly, you can take 4 upon 4, 5 upon 5, 10 upon 10, 20 upon 20, and you can find infinite number of equivalent fractions for a single fraction. Okay, this is the simplified form. It can't be solved further, but these can be solved. It can be solved to obtain 3 by 5 again. This is the concept of equivalent fraction. Example number 2. Ramesh solved 2 by 7 part of an exercise while Seema solved 4 upon 5 part. Who solved lesser? So question is saying there are two students, Ramesh and Seema. They are solving a same exercise. Ramesh solved 2 by 7 part of that exercise and Seema solved 4 by 5 part of that exercise. It is asking who solved lesser. So I have written like this: Ramesh, below him his mark is his contribution, that is 2 by 7 that he has done, and Seema 4 upon 5. Just by looking, you can guess that who has done more or less, but that wouldn't be correct always. To find the correct answer, to compare them exactly, we have to see whether their denominator are same or not. You can see Here denominator is 7, here denominator is 5. So we can't compare like this. First of all, they are unlike fractions. Unlike fractions are those fractions in which denominator is different. So first we will make them like fractions to compare. How do we make like fractions? By making the denominator same. Let's see how to make it same. To compare, we will have to make them like fractions, that is making denominator same. For that, I will take LCM of 7 and 5. LCM of 7 and 5, you all know how to find LCM. I have written like this. First by 7, 7 ones are, 5 is left, 5 ones are, 1s are. So 7 5s are 35 is LCM of 7 comma 5. That is why we have to make both denominators as 35. Okay, let's see how. The numbers were 2 upon 7 and 4 upon 5. 2 by 7 is the part done by Ramesh, 4 by 5 is the part done by Seema. Can we do like this? Can we write 1 upon 1 and here also? Does it change anything? No. So we can do this thing. Now see how this 1 and 1 will help us in making denominator 35. Let's see. In the place of 1 upon 1, can I write 5 upon 5? Yes, because 5 ones are 5, it is 1 only. But I have written like this. Why I have written 5 only? Because 7 5s are 35. This will give me denominator 35, which was required. Similarly, in the second fraction, I have multiplied with 7 upon 7, which is again 1 only. So, why 7 upon 7? To make the denominator 35. Okay. So, we have got 2 5s are 10, 7 5s are 35, 4 7s are 28, 5 7s are 35. So, these are the new fractions, or we can say they are the equivalent fractions, and you can just see now you can compare them easily because the denominator is same, and you can see 28 is more than 10. So we can write this symbol. This says that Seema has done more work and Ramesh did lesser work. Okay, now see example number 3. Samira purchased 3 1 by 2 kg apples and 4 3 by 4 kg oranges. So given to you are mixed fractions. What is the total weight of fruits purchased by her? Very easy. First of all, we will convert these mixed fraction into normal fractions. After that, we will add these fractions to get the total weight. Easy. Let's start. Samira purchased 3 1 by 2 kg of apples. We all know how to solve a mixed fraction. It is simple. 2 3s are 6 plus 1 7 upon 2 kg of apples. Okay, first ratio. Second is she bought 4 3 by 4 kg of oranges. Again a mixed fraction. 4 4s are 16 plus 3 is equal to 19 upon 4 kg oranges. So this is the fraction for apples. This fraction kg is for oranges. Now total weight will be given by addition of these two fractions. But again, first check, are they like fractions? Because to compare two fractions, to add two fractions, or to subtract two fractions, they first must be made like fractions. And we know as the denominators are different, here denominator is 2, here denominator is 4, so we can say they are not like fractions. So first we will make them like fractions. To make them like fractions, we will take LCM of 2 and 4. LCM of 2 and 4 is 4. You can check on your own. Okay. Now, same process. I have taken 1 by 1 to 7 by 2. Here it is already 4. So nothing is required to change. This becomes 2 by 2 because we want denominator to be 4. Hence I multiplied with 2 by 2. 2 2s are 4. 7 2s are 14. Now As the base is same, we can add them easily by taking LCM of base. 4 and 4 are same, it becomes 4, and above it 14 plus 19 can be added as 33. Okay, you must be thinking, why not I have done 8 over here? It is not done because LCM of 4 and 4 is 4 only. In denominator we never add. Okay, in denominator we take LCM. So LCM of 4 and 4 is 4 only, not 8. Okay, and 14 plus 19 is 33. Now it is a improper fraction, so I will divide by 4 to write like this: 8 1 upon 4 kg. Example number 4. Suman studies for 5 2 by 3 hours daily. She devotes 2 4 by 5 hours of her time for science and mathematics. How much time does she devote for other subjects? Again, a simple statement. Try to understand. This girl Suman, she is studying these many hours daily. Out of these hours, she studies these hours for maths and science. Question is asking how much time she is devoting for other subjects. Very easy. This minus this. Only issue is now they are fractions, so we have to take care of some things. Let's write them. First of all, total time is 5 2 by 3. So we will write it in normal fraction form. 3 5 is 15 plus 2 17 upon 3, and time for math science is 2 4 by 5, that is 5 2 is 10 plus 4 14 upon 5 hours. So time given to other subject will be given by total time minus time for maths and science. So this is the numbers: 17 by 3 minus 14 upon 5. I told you, when you want to compare fractions, when you want to add them, or when you want to subtract them, the best way is to make the denominators same, because here they are unlike fractions. First we will make them like fractions, and to make them like, I will take LCM of 3 and 5. LCM of 3 and 5 is 15, so I have to make denominators of both of them as 15. To make 15, I can see if I multiply 5 with 3, it becomes 15. That is why I multiplied with 5 upon 5. Similarly, 5 can be made 15 as multiplying with 3. So I multiplied with 3 upon 3. Now 3 5s are 15, 5 3s are 15. Bases are same. 17 5s are 85, 14 3s are 42. Now last step, again you must be thinking that it will be 15 minus 15, 0. No, fractions are not solved like this. We take LCM of denominator, and LCM of 15 and 15 is only 15. Okay, now, and the numerator can be solved very easily. 85 minus 42, that is 43 upon 15. If you observe, it is a mixed fraction, that is why, sorry, it is a improper fraction. So I have written it in this form, that is mixed fraction. Now some questions from phase 2.1. You can try these two questions on your own. You have to solve these examples very easy. In this one, you can do solve first these two, and then the answer comes. That answer and this part you can solve and get the answer. Okay. In question number 2, you have to arrange in descending order. Descending order means first the largest one will come, then less than that, and then the least one. Okay, again same procedure. You have to see the number. There are 3 numbers, no issue. Take their denominator. You can see they are unlike fractions. So first of all, take LCM of 9 3 and 21, and then make the denominator same of all these 3. After that, you can easily arrange them in descending order. Similarly, in this case, take the 3 numbers, make their denominator same by taking LCM, and you can find and arrange them in descending order. Thank you.